Dear students, I welcome you all for this flip mode video session, and today's discussion of our topic is MBR. MBR stands for Membrane Bioreactor, which is one of the advanced wastewater treatment system employed in industries. And we have in the last class, it is to make you recall that we have already learnt about the stages in the treatment of wastewater. That is basically you know about the screening, grit removal, and PST, primary settling tank, aeration, which will be a part of the ASP, and secondary settling tank, and followed by filtration. It can be through a sand filter, which is either slow sand filter or a rapid sand filter, followed by disinfection of the treated effluent to achieve a high quality and to make it free from pathogens. So these are the several stages of treatment, conventional treatment system we have talked about so far. And today what we will going to learn is a part of the advanced treatment technique. So MBR, as stated in the literature, can be is being applied basically for the wastewater which is degradable in nature, namely dairy, brewery effluent, etc. And it is all, there are some literatures which even mention MBR can be applied for automobile, paint and cosmetic industry wastewater, which will be slightly having higher COD to lower BOD ratio. So what happens in MBR is a question. So once again I'll tell you, membrane bioreactors are composed of two primary parts. One is biological unit that is responsible for the biodegradation of the waste compounds, and membrane module which separates the treated water from a mixed liquor. In this image you can see that what you have to what quality of the wastewater that you have to subject for MBR is only you have to do solid removal and PST, and then aeration is still optional, and you can fix your MBR. So thereby you can bring down your treatment units in a treatment facility. So let me go to few advantages that we have by using MBR or conventional treatment system. You can retain a large amount of suspended matter, most soluble compounds within a bioreactor, which leads to excellent effluent quality capable of meeting stringent discharge requirements. The possibility of retaining all the bacteria and viruses, thereby resulting in a sterile effluent, eliminating extensive disinfection and corresponding hazards related to disinfection byproducts. All these will be avoided by using MBR. And also there are certain advantages over operating environmental conditions such as HRT and SRT. Since you retain your solids for a longer time, you can have a better control over your degradation of even on the solids also. So suspended solids are not lost in the clarification step, and total separation and control of the solid retention time, hydraulic retention time are possible, enabling optimum control of the microbial population, and flexibility in operation is also possible. The absence of clarifier enables sensitive and slow growing species, especially like nitrifying bacteria, to develop and persist in the system. Membrane, this is a point to be highlighted. Membrane not only retains all the biomass but also prevents the escape of exocellular enzymes and soluble oxidants, creating more active biological environment inside the reactor. MBRs eliminate difficulties associated with settling, and these are you can control better fluctuations, nutrient removal, and all these are possible using MBR. There are certain system configurations to be understood. So now you have got a brief picture. Like with this image, it is very clear that you have a microorganism and a physical separation. So this degradation will happen and you are getting a clean effluent. Okay, this is the system working happening. So now I'll move to some of the system configurations. How you can have your membrane, whether it is inside the reactor or you can have ASP and followed by membrane module. So based on this concept, there are two types. One is integrated MBR and external MBR. In an integrated MBR, in the ASP, or where you are doing aeration of your biological degradation through aerobic environment, you can place your membrane as shown in the very first slide. So this is the integrated membrane you are viewing. So that is integrated MBR, and one more is external MBR. It is a second configuration wherein you need to recirculate your wastewater. So wastewater will be treated, biological degradation happens in ASP, and you will be passing that wastewater through the external module. So these are the configuration, and what material should be used to in the market. A lot of membrane materials are available. So it can be organic in nature, inorganic in nature. Some of the examples I have written here: polyethylene, either sulfone. These are some of the materials that membrane can be made up of. It can even be sometimes inorganic, which is ceramic in nature. So, and the membrane pore sizes normally range from 0.01 to 0.4 micron. However, it will vary on the type of membrane that is employed, and fluxes normally range between 0.05 to 10 meters per day. So this is about the pore size and the basic material of the membrane. There is one more configuration to be understood based on the arrangement is concerned. That is, either it can be tubular or a flat sheet type. So here is a small video. This is a whole set of hollow fiber membrane module. It will be having a single unit having multiple cassettes. So this is the single unit that's been animated and shown to you. It's a hollow fiber membrane. Diffusion will be there. A diffuser will be placed at the bottom. So you can see the pollutant molecules rising up because of the diffuser, and treated effluent moving up. Since suction will be created at the top end, the water will be moving up. So this is since suction is created at the top end, the water will flow. The arrows shown. That's a small single unit being shown. So whole unit will be made up of such several units. So here is one more video to explain you the one more type of membrane unit, that is flat sheet membrane. You can have at a single point you have a wastewater. It is something like this video will explain you something like an external MBR. It's a metallic frame over which the perforated membrane is fixed, and again a diffuser at the bottom, and you can see that suction is created at the top end and the water is being treated. So based on the fouling effect or by measuring TMP, transmembrane pressure, it can be shut down, and it can be the deposition over which can be cleared by stopping the negative suction head created at the top end. So this is a cassette, this and is a whole module being shown to you. So this is how the MBR will work and can be used. So with this you have learnt about, you are introduced to what is MBR, what is advanced, how MBR is a part of advanced wastewater treatment, what are the materials it is made up of, configurations, and in the next class we will talk about what is TMP, how the transmembrane, that is transmembrane pressure, what modifications we can make to improve the efficiency of MBR, what is fouling and all those things. So I thank you here. will meet in the class.